Okay, so this is the key to section 2.6 part 2, and this is the one that's dealing with the composition of two functions. And so remember the definition you have to use here is that when you see f composed with g, so f composed with g at x, then that's just f of g of x. So that's how you write f composed with g at x. So you say f of g of x. And then it doesn't matter whether it's f composed with g or g composed with f. It's still the same definition. So it's still the same, like if you said g composed with f at x, then that's just g of f of x. So the first function listed here is the first function listed here. So you're taking g of x and you're inputting this into f of x. You're taking f of x, you're inputting this into g of x. Okay. So in number 1a, you're going to find f composed with g at 2. So that's how you read this. So you say f composed with g at 2. So by definition, that's the same thing as saying f of g of 2. And so remember, we got to find g of 2 first. So we got to find this first. So I go to my function g, and where we see the variable x, I input the number 2. So this is my input, and I want to get this output here. So x is 2, so I go to function g. Make sure you're using the function g, because that's where you're substituting the 2 into. So you want to find g of 2. So what is y when x is 2? So I'm going to get, remember g of x is this, so it's negative 5x plus 2. So in place of this variable, I'm going to substitute 2. So I'm going to get negative 5 times 2 plus 2. And so that's negative 10 plus 2, which is negative 8. So what I found, now remember, is that g of 2 is negative 8. So that's not the answer to this composition, though. All I found was this. So now I've got to take this output, and it becomes the input of f now. So in other words, I've got to find what f of negative 8 is, because that's what I just found g of 2 to be. So the first step to do is to find this g of 2, the innermost output that you got to find. So g of 2, find that, then that negative 8, that y value, then becomes the input of f of x. So that becomes the input for x now. All right, so f of negative 2, remember f of x is this, it's 6 minus 3x. So in place of x, I'm going to substitute negative 8. So this becomes 6 minus 3 times negative 8. So that's 6 plus 24, which is 30. So f composed with g, so that is f composed with g at 2 equals 30. So in this blank, you're going to put 30. Okay, next one is we want to find b composed with g at negative 3. So in 1b, you want to find f composed with g at negative 3. So again, definition, we're going to say that's going to be f of g of negative 3. So just like with the previous one, we're going to find g of negative 3 first. So I'm going to, in the function g, I'm going to input the number negative 3 into x. So g of x, remember, is negative 5x plus 2. So it becomes negative 5 times negative 3 plus 2. So that's 15 plus 2, which is 17. So I found g of negative 3 to be 17. That's what I just found. So I'm going to take that number, and that's going to be the input now for f of x. So now I'm going to find, remember, that's what we just found here. So now I'm going to find f of 17. So g of negative 3 is 17. So now I'm going to input 17 into the function f. So f, remember, is 6 minus 3x. So it becomes 6 minus 3 times 17. So that's 6 minus, and that is 51. And so 6 minus 51 is a negative 40, what's that, 45? It's a negative 45. Okay, so f composed with g at negative 3 is negative 45. So f composed with g at negative 3 is this. All right, so that's going to be the answer for 1b. So 1b, you're going to say negative 45. All right, now the next one, now And the next one you want to find f composed with g at x. Now notice that when I substituted numbers, when I was composing at a number, I ended up with a number. So if I compose at a real number, I get a real number. If I compose at a variable expression, I'm going to get a variable expression. So just keep that in mind. Okay, so in 1C, this is what we have. We have f composed with g at x. Remember, by definition, this means f of g of x. So just like when we found g of -3, right now, and whatever that was, I substituted g of -3 into this. Remember, g of -3 was 17. So I replaced g of -3 with 17. I do the same thing here. So I'm going to replace g of x with whatever that function is equal to. So that function is equal to -5x plus 2. So this becomes f of -5x plus 2. So remember, that's what g of x is equal to. So g of x is this function here. So now in place of x in my function f, so remember f of x was this. So f of x was 6 minus 3x. So that's what f of x is. So in place of this function f, I'm going to substitute this expression in for x. So remember, so in place of x, this is in place of x, where I receive an x, I'm going to substitute this expression. So this becomes 6 minus 3 times, in parentheses, because all of this right here has to be multiplied by -3. So in parentheses, I'm going to have -5x plus 2. And then distributing, I get 6 minus, a -3 times -5x is a positive 15x. A -3 times a positive 2 is a -6. And all you left here, when you combine like terms, these constants cancel out, you get 0. And so all you're left with is 15x. So what I found now is this. What I found was that f composed with g at x equals 15x. So that is the answer to 1C, 15x. Okay, 1D, we have this now. So now we have g composed with f. So 1D is this now, g composed with f at x. So again, by definition, that's going to be g of f of x. And so this time, remember in the previous one, I replaced g of x with that function, -5x plus 2. Now I'm going to replace f of x with what its function is. So its function is 6 minus 3x. So this will become g of 6 minus 3x, because that's what f of x is equal to. So f of x equals this. So now what that says is I go to my function g, which is -5x plus 2. I go to my function g, and where we see the variable x, I'm going to substitute this expression. So this becomes -5 times 6 minus 3x plus 2. And then getting rid of the parentheses, I'm going to distribute. So I get -30, -5 times 6, -30, and -5 times the -3x is a positive 15x, and then plus 2. And then combine like terms, a -30 and a positive 2 is a -28 plus 15x. Alright, so that is g composed with f at x. So that's what g composed with f at x is. So that's what we get when we take f of x and we plug it and we put it into g of x. So we get this new function here. So the answer to 1D would then be -28 plus 15x. Okay, now number 2, my functions are different, but the idea is the same. We're going to be doing the same thing, but the functions are different this time. So in 2A, you want to find g composed with f at 3. Well, by definition, that is g of f of 3. That's what it equals to. So I got to find f of 3 first. So let's see. F of x is this now. So f of x is 5x plus 1. So if we want to find f of 3, so that means I go to my function f, and where we see the variable, I'm going to substitute 3. I'm going to input 3. So I get 5 times 3 plus 1. So that's 15 plus 1, which is 16. Okay, now that's f of 3. So then we'll replace this f of 3 with 16. So that becomes my new input. So in place of the variable x, now I'm going to substitute g. So that becomes my input. So remember, g of x this time is this. It's 5 minus x. So that's g of x this time. So where we see the variable x, I'm going to substitute 16. So this is going to be g of 16 then would be 5 minus 16. And 5 minus 16 is a negative 11. So that's what I found g composed with f at 3 to be. So g composed with f at 3 equals negative 11. So this right here becomes negative 11. Okay, part B, this time you want to find f composed with g at 3. So what does that look like? So this is 2b. So you want to find f composed with g at 3. Again, by definition, this will be f of g of 3. All right, now remember I got to find g of 3 first. All right, so I got my function g, and wherever we see the variable x, I'm going to substitute 3. So that's what that says. So this becomes 5 minus 3, which is 2. So g of 3 becomes 2. So now I've got to find f of 2. So to find f of 2, now I go to my function f, which is 5x plus 1, and wherever I see the variable x, I'm going to substitute 2. So this becomes 5 times 2 plus 1, so that's 10 plus 1, which is 11. So f of 2 is 11. So that implies that f composed with g at 3 equals 11. All right, so that's 11. All right, so again, those are opposites. So g composed with f at 3 and f composed with g at 3, those are opposites. Okay, now 2c. 2c. Now this time, remember, notice when I compose two functions at a real number, I get a real number. Notice I'm composing these two functions at the value x, at the expression x. So 2c, you want to find f composed with g at x. So again, by definition, that is f of g of x. Well, remember, g of x is this. So this is g of x, 5 minus x. So what that means is I'm going to replace g of x with this right here. So that becomes f of 5 minus x. So that's what that becomes. So this expression here becomes my input for f. So now I'm going to go to my function f, which is 5x plus 1. And where we see the variable, I'm going to substitute 5 minus x. So that's what that means. That's what I've got to do. So then this becomes 5 times, and then remember, in parentheses, you're going to substitute 5 minus x, and don't forget you're adding plus 1. So notice 5x, x becomes 5 minus x plus 1. 5x plus 1. 5 times x, which becomes 5 minus x plus 1. Now distribute and get rid of the parentheses, I get 25. 5 times a negative 5x is a negative 5x, and then plus 1. Combine like terms, I get 26 minus 5x. Or you could have said negative 5x plus 26. It does not matter. And so then the answer, so what I found then again was that f composed with g at x is equal to this. All right, so that's 26 minus 5x. Okay, now in number 3, again the functions are different, and then notice this time in the previous ones these were linear functions. Linear functions, linear functions. This is linear, this is quadratic now. Alright, so in 3a, you want to find g composed with f at negative 1. So g composed with f at negative 1. Again, by definition, this means g of f of negative 1. That's what that means. So notice how it looks. G of, in parentheses, f of negative 1. So now we've got to find f of negative 1, though. So f of negative 1, we've got to find what that is. So remember f of x, though. So again, I got to go to my function f, and where we see the variable, we substitute negative 1. So f of x is 4x squared plus 3. So in place of this, I'm going to substitute negative 1. So I get 4 times negative 1 squared plus 3. And then order of operations, square first. Negative 1 times itself is 1. 1 times 4 is 4. 4 plus 3 is 7. So f of negative 1 is 7. That's what I just found. So this becomes 7. So now I'm going to input 7 into my function g. So g of x is this linear function, 3x minus 2. So in place of the variable x, I'm going to substitute 7. So this becomes 3 times 7 minus 2. So notice 3x minus 2. That's what it says. 3x, and in place of x, I substitute 7 minus 2. And then order of operations, I multiply before I subtract. So that's 21 minus 2, and so the answer is 19. So what I found is that g composed with f at negative 1 is equal to 19. So 3a is 19. All right, 3b, let's look at 3b. Now notice this time for 3b and 3c, I'm composing these at the variable x. So I'm going to end up with the variable expression. Okay, so 3b, that's what you want to find, 3b. So in 3b, you have f composed with g at x, by definition, is f of g of x. So now I got to find g of x. So g of x, remember though, is just this. It's 3x minus 2. That's g of x. So if you go back and you look at your function, that's 3x minus 2. And so now this becomes f of, remember g of x is this, so that becomes f of 3x minus 2. So this says I go to my function f, which is 4x squared plus 3, and wherever we see the variable x, I'm going to substitute 3x minus 2. Now be careful, this time it's being squared, so this is quadratic this time. So f of x here is a quadratic function. So then that becomes 4 times, in parentheses, remember x, I'm substituting this expression into x, so 4 times 3x minus 2 squared, and then plus 3. So notice 4x, x becomes this expression, squared plus 3. That's what it says, 4x squared plus 3. Now be careful, you can't distribute here like you could in some of the others. The reason is because this is not an exponent of 1. It's squared. So remember the order of operations says I've got to square first and then multiply. So it's not, you're not saying 4 times 3x squared, right? When you actually square this becomes a 9x squared. So this is 4 times 9x squared, not 4 times 3x. So you got to be careful. So you got to square and then distribute. So let's go ahead and figure out what 3x minus 2 squared is. So 3x minus 2 squared, remember, is 3x minus 2 times itself. And so notice I'm multiplying two binomials, so I can use the FOIL method. So when I use the FOIL method, for first times first, so 3x times 3x is 9x squared. The outer, 3x times a negative 2, is a negative 6x. The inner, now since those are the two same binomials, the outer and the inner should be the same, or will be the same. Negative 2 times 3x is a negative 6x, which is what we should have gotten. And then a negative 2 times a negative 2 is a positive 4. And so combining like terms, I get 9x squared. This is negative 12x, and then plus 4. Now remember, all I found was this. All right, so that becomes, this becomes right here, this right here. So now we replace this 3x minus 2 squared with this trinomial. So this becomes 4 times 9x squared minus 15x plus 4. All right, so, and then plus 3. So now I'm going to distribute. And so this becomes 36x squared minus, and then that's going to be, what's that, 60x? And then plus 4 times 4 is 16, plus 3. Combine like terms, I get 36x squared minus 60x, and then plus 19. Right, so that is, this right here is f composed with g at x. So that's what f composed with g at x equals. So it's equal to 36x squared minus 60x, and then plus 19. All right, and let's find g composed with f at x. So part C, you want to find g composed with f at x. So again, by definition, this is g of f of x. So notice how it looks. So now in place, now I've got to substitute f of x first. So that's going to be 4x squared plus 3. So this becomes g of 4x squared plus 3. So now that says, and I go to my function g, remember g of x is this, 3x minus 2, that's g of x. So in place of the variable, I'm going to substitute, I'm going to input 4x squared plus 3. So this becomes 3 times 4x squared plus 3. So in place of the variable x, I substitute this expression. So 3x, and x becomes this, and then minus 2. Now all I have to do now is get rid of the parentheses. I'm going to use the distributive property. See, here I can use the distributive property because that's a 1. And so 3 times 4x squared is 12x squared, and then 3 times 3 is 9, and then minus 2. So your final answer would be 12x squared plus 7. All right, so that becomes this. So 12x squared plus 7. Okay, so that's going to take care of the key to worksheet 2.6 part 2, which dealt with composition of functions, composing two functions.